Gaussian elimination is a computational process for transforming a matrix from one form to another. And the new form could be upper triangular, it could be diagonal, row echelon, reduced row echelon, and so forth. The transformations are made by applying one or more of the elementary row operations. These are the elementary row operations. Interchange two rows, multiply a row by a constant, add a multiple of one row to another row. Matrix that's been transformed this way is said to be row reduced to its new form. And the elementary row operations here are the matrix equivalent of manipulations used to solve a set of linear equations. As an example, let's row reduce this matrix to row echelon form, and then later we will reduce it to the reduced row echelon form. To begin, the matrix that I want to row reduce is called A, and I'm going to make use of one of Maple's tutors, the Gaussian Elimination tutor. Now, this matrix to this tutor represents a set of equations. And the set of equations is in four unknowns. So we have three equations in four unknowns, and the equations are homogeneous, so the equals 0 is not written but is assumed by the tutor. If we check augmented, then we are treating this as a set of three equations in three unknowns, x1, x2, x3, where 2, 5, and 3 on the right side are the values that these expressions have to attain. And this line here in the matrix represents where the equal sign would be in the equivalent set of equations. So that's the form that we want to work in, thinking of this as an augmented matrix. And we will use these tools on the right to implement the elementary row operations. Interchange two rows, multiply a row by a constant, add a multiple of one row to another. I would like to avoid fractions, because if you introduce fractions, you then have to juggle extra mental arithmetic while you're trying to figure out what is my next step. So the first thing I'm going to do is move equation 3, or row 3, up to the top where I have row 1. So I want to interchange row 1 with row 3. And so the 1 is going to be useful in eliminating or converting to a 0 the 3 and the negative 4 in rows 2 and 3. And the way I'll do that is I will multiply row 1 by negative 3. So I'm going to multiply row 1 by negative 3 and add that to row 2. And then I'm going to multiply row 1 by 4 and add that to row 3. So I have these two zeros. And now I want to make use of row 2 to make a 0 in column 2, row 3. And to do that, I simply add row 2 to row 3. 1 times row 2 added to row 3. According to Maple, I have achieved a row echelon form. Now, some users may look and see 1, 1, negative 1 and think row echelon form by definition has all of these leftmost elements 1. But there are many books, and it's split about 50-50 as far as I can tell, do not have the requirement of normalizing these elements, these leftmost elements, to 1 in order to be in row echelon form. And clearly, this tutor in Maple is following the paradigm of row echelon form does not have to be normalized. Now let's row reduce to row echelon form. We will again use a tutor. This one is called the Gaussian Elimination tutor. Again, let's make this an augmented matrix. The difference between reduced row echelon form and a row echelon form is that we'll have a lot more zeros. So we have to do some of the same work that we just did. Interchange row 1 and row 3. Make 2 zeros in column 1. So it's -3 times row 1 added to row 2. Then it's 4 times row 1 added to row 3. Now we will make this 0 in column 2. So it's 1 times row 2 added to row 3. But now we must make a 0 above the 1 in row 2. In other words, we try to make as many zeros in a column as we possibly can. So we will add 1 times row 2 to row 1. 1 times row 2 added to row 1. And so we have the 0 above. Now, if this were being programmed, computer program, where you're not looking at the numbers, this would be changed to a 1 so that the arithmetic could be consistent. But since we're doing this by hand, we see that this is negative, but these two numbers are positive. So if we multiply row 3 by 16 and add it to row 2, we'll make a 0 here. So let's multiply row 3 by 16, and you'll notice that we no longer have a 16 in here, so we'll have to type our own 16, and that will be added to row 2. Okay, so we have this 0, and now we multiply row 3 by 12 and add that to row 1, and we see that we have one more step, which is to multiply row 3 by -1. So that's this multiply, so I believe we'll find a -1 in here, and we want to multiply row 3 by that -1, and the tutor has realized we are now in reduced row echelon form. As many zeros as possible above and below the main diagonal, 1s, that's the normalization step. And if this were a set of equations, we would see here x1 has this value, x2 has this value, and x3 has this value. Alternatively, we can reduce the matrix to row echelon form, or a row echelon form, through the context menu system. So if we bring up the elementary operations dialog, we can begin with a swap row, interchanging row 1 and 3 as we did earlier with the tutor. And then we can zero out below the 1, 1 position by the add row operation. We want to multiply row 1 by -3 and add that to row 2. And then we will multiply row 1 by 4 and add that to row 3. And we have these two zeros. And finally, if we add row 2 to row 3, one times row 2 added to row 3, we will have achieved a form of the row echelon form of the matrix. Underlying the functionality in the tutors and in the context menu is a collection of commands: add row, multiply row, swap row, that can be used to do these computations in a stepwise fashion. So we could begin by swap row, apply that to the matrix A, interchanging rows 1 and 3. And so here now you have a record of exactly what it was that was done. And then we want to multiply row 1 by -3. So this would be add row. And we want to apply it to the matrix whose equation label is 1. So we use Control L1. Okay, so now we have to give 3 numbers. The row we are multiplying, the row we are adding to, and the scalar that we multiply a row by. So the command would be thought out as to row x, so this would be to row 2. Add a multiple of row 1, and that multiple is -3. Now when we're done, what we could do is read this backwards and say -3 times row 1 added to row 2. We've created this 0. Let's do it again with making a 0 here, which is a -4. Add row, and the matrix is now has equation label 2. We want to add to row 3 a multiple of row 1, and that multiple is 4. And if you read it backwards, it's 4 times row 1 added to row 3. And a final step to get a row echelon form would be add 1 times row 2 to row 3. So that would be another add row. The equation label is now 3. Okay, so if we think backwards, the third number is a 1, because it's 1 times. We are multiplying row 2, and we're adding it to row 3. So to row 3, we will add a multiple of row 2, and that multiple is 1. And we have again achieved a row echelon form. We have mentioned that the elementary row operations parallel what you would do if you were solving a set of equations as equations. Now, these are representative of the steps we went through as we row reduced this matrix to row echelon form. Well, I've already swapped row 1 with row 3, and then we made 1 0 in the first column, then we made the second 0 in the first column, and then we've made a 0 in the second column. If we interpret the matrix as augmented matrix as representing this set of equations, a solution technique might be multiply the first equation by -3 and add it to the second equation. So we need to give that a new name, so that will become Q4. And Q4 will be -3 times Q1 added to Q2. And this equation, y plus 16z, is what this middle row now represents. The next step was to eliminate the -4 here, so we again need a new name, Q5, and we achieve that by multiplying row or equation 1 by 4 and adding that to equation or row 3. And this represents the third row here, -1 times y minus 17 times z equals 14. And the last step that we performed here was to add 1 times row 2 to row 3. So again, we need a new name, or at this point we won't even put a name. We will take 1 times the middle row. But now the middle row, here, let's see if we can see that more clearly. The middle row consists of row 4 amidst the 3 rows that are labeled 1, 4, and 5. And so we really want to add 1 times row 4 to row 5, or equation 4 to equation 5. So Q4 plus Q5. And that represents this row, -1 times the third variable equals 10. And so we see that the elementary row operations are simply a simplified way, compressed way, of doing the manipulations you would go through solving a set of equations, but you're not dragging around the variables. Makes the arithmetic a little bit easier to handle.